Last week, I saw a bit of celebration in the Linux kernel around what seems like a pretty random change. From keyscook, we can remove strncopy from the Linux kernel finally. I did the last 6 instances and dropped all the implementations. Over the last 6 years working on this, there were 362 commits by 70 contributors. Thank you to all of these people here, and especially to Justin Stitt, who took on the brunt of the work. Now, I've written a tiny little bit of C in the past, but not enough to say I was good or competent, so I was kind of curious as to why you'd want to drop an entire C function from the kernel. What problem was this causing? Why shouldn't it be here? Because the function itself is not some weird esoteric function. It's a substring function. It copies part of a string into a destination. That's all it does. At least, that's all it should do. This work was started by keyscook way back in 2020, remove all strncopy uses. And here we have the related merge into the kernel. strncopy has been a persistent source of bugs due to its ambiguous intended usage and frequently counterintuitive semantics. It may not null terminate the destination. What does that mean? This is the way that C marks the end of a string. So you have hello world and then the null character at the end. When the null character is there, it says, hey, this is the end of the string. There's nothing more to read. By not having this there, this can lead to a situation where you end up reading off the end of the string. What does that lead to? Well, potentially undefined behavior, some memory corruption, or, very important for the kernel, it's segfault. And segfaulting is probably your best case scenario. Having things immediately crash and immediately die, that's great. Much worse than that is a situation where an attacker knows that there is a read off the end of the string and is then able to access memory that they otherwise shouldn't be able to access. Concerns around this function and the existence of the function is certainly not new. So this is a Stack Overflow post from 16 years ago, back when Stack Overflow was actually used and was actually useful. The strncopy function was designed with a very particular problem in mind, manipulating strings stored in the manner of original Unix directory entries. These used a short fixed-sized array of 14 bytes, and a null terminator was only used if the file name was shorter than the array. So potentially you have a string that does not have an indicator for the end of the string. Now, this can be resolved manually after using the function by just applying the null terminator to it, but if you don't do that, potentially a string with no null terminator. The second problem with this is it unconditionally zero pads to the full length, which isn't always needed. If you have a source string that is, say, 10 characters long, and you want to take 5 of those characters and then put them into the destination, which is, let's say, it can support up to 10 characters. So you take those 5 characters, you put them into the destination, which has up to 10 characters, now you have all of this empty space. What the function does is it takes that empty space and then just fills all of it with null characters, and this is inefficient, it's a waste of memory, and there's no reason to do so, except for the fact that this function was sort of designed for a very specific purpose. Now, I showed you that Stack Overflow post about strncopy, but concerns around this function are not new. Like, this is not a recent thing. This is a post from 2013, stop using strncopy already, and there are older ones out there as well. This is just a popular one that was shared around. If people have understood it's a problem for a long time now, why is it still being used, and why is it only very recently that this was pulled out of the kernel? Firstly, there's a lot of people that actually don't know it's a problem, because the reason why people were using it is because of another problematic function. All of this time, we've been talking about strncopy, copy part of a string. There is another function that this was supposed to replace. strcopy, copy a string. Note the lack of the n there. The n is the size that you want to copy. When you have strcopy, it just copies the entire thing. What is the problem with strcopy? Simply the fact that you're copying an entire string. So unless you go and check the length of that string, it is very easy to put yourself in a situation where you are copying a string that is larger than your destination buffer. And if you do that, you write past the end of the buffer and things go very badly for you. strncopy is supposed to resolve that problem by giving you the ability to select how much of the string you want. This gives you a, at least perceived level of boundary checking. However, it's very easy to calculate the size wrong, and this still to cause a problem. For a very long time now, there's been replacements to both these functions, and for the most part, the problems no longer exist, although those functions have other problems, and those can be misused anyway. But these core issues should not exist in any modern code. So what the kernel has done is, instead of just calling strncopy and strcopy all around the codebase and then expecting the individual developers to ensure they include the check they need, what they've done is just defined safe versions of the function that are defined in one place. You can call them anywhere in the codebase and do the checks for you. So, strscopy for null terminated destinations, strscopy pad for null terminated destinations needing 0 padding. So if you need that padding there is a separate function. The main function does not automatically pad for you. str to mempad for non-null terminated fixed width fields, memcopy and pad for bounded copies with explicit padding, and memcopy for known length copies. Remove the generic implementation, its declaration, the fortify source wrapper, and associated tests. So if you want to make use of this functionality, now you don't have to make sure everything is clean yourself. It's all done in one place. And that's pretty much what was being suggested in this blog post over here. End functions considered dangerous. The dangers of strncopy underscore snprintf, which is different from snprintf, and wc sncopy should be equally well known, but apparently they are not. These functions let you specify the size of the buffer, but, and this is really important, they do not guarantee null termination. If you ask these functions to write more characters than will fill the buffer, then they will stop, thus avoiding the buffer overrun, but they will not null terminate the buffer. In order to use these functions correctly, you have to do this sort of nonsense and make sure you're actually adding the null terminator at the end. A non-terminated string in C and C++ is a time bomb just waiting to destroy your code. My understanding is that strncopy was designed for inserting text into the middle of strings and then was repurposed for secure coding, even though it was a terrible fit. Meanwhile, underscore snprintf followed the strncopy pattern, but snprintf did not. That is, snprintf guarantees null termination, but strncopy and underscore snprintf do not. Is it any wonder that developers get confused? Is it any wonder that developers often do this? Make snprintf available on Windows. Don't ever do this. These two functions are different. And defining a macro that basically turns them into the same thing. strlcopy is designed to solve the null termination problems. It always null terminates. It's certainly an improvement over strncopy, however isn't natively available in VC++. strcopy is a similarly named Microsoft design defect that appears to behave like strlcopy, but is actually a security bug. It uses structured exception handling to catch access violations and then return, so in some situations it will cover up crashes and give you a non-terminated buffer. I didn't mean to scroll there. Awesome. Wide characters? Worse. swprintf is a function that defies prediction. It lacks an n in its name, but it takes a character counter. However, it doesn't guarantee null termination. It's enough to make one's head explode. You know, C is an interesting beast of functions upon functions upon functions, all to do mostly the same thing. But wait, it's actually worse, because it turns out that programmers are imperfect human beings, and therefore programmers sometimes pass the wrong buffer size. Not often, probably not much more than 1% of the time, but these mistakes happen, and being careful doesn't actually help. I've seen developers pass hard-coded constants, the wrong ones, pass name constants, the wrong ones, use size of, the wrong buffer, use size of on a wchar array, thus getting a byte count instead of a character count. I even saw one piece of code where the address of the string was passed instead of the size, and due to a mixture of templates and casting, it actually compiled. Passing size of to a function that expects a character count is the most common failure, but they all happen. Even snprintf and strlcopy are misused. Using annotations and analyze can help catch these problems, but we can do so much better. What can we do? keep using the function. We are programmers, are we not? If the functions we are given to deal with strings are difficult to use correctly, then we should write new ones, and it turns out it is easy. Here I present to you the safest way to copy a string to an array. Instead of just using the function throughout the code base and trying to ensure that you use it safely every time, if you're using it the same way throughout the code base, define a safe version of it. Similar functions can obviously be made for all of the string functions you use. You can even invent new ones like sprintf cat safe. In fact, when I write a member function that takes a pointer and a size, I usually make it private and write a template wrapper to handle the size. It's a versatile technique that you should get used to using. Templates aren't just for writing unreadable metacode. Obviously, if you couldn't tell, this developer here is a C++ programmer, but the same applies here to C. Just define a safe function to use instead of calling the unsafe one and then trying to write guard cases for it every single time. You know, it's very rare, but sometimes we do development-related things here as well. I know, crazy. It's not always drama. Sometimes you might learn something and it might be useful. I don't know. Anyway, if you liked the video, go like the video, go subscribe as well, and if you really liked the video and you want to become one of these amazing people over here, check out the Patreon subscribe to the Brodie page linked in the description down below. Like the video, subscribe as well, and make sure you use the right function.